Hi everyone. In this session, I'm going to talk about subnetting. I already covered some of these concepts in previous sessions, but it is a good recap uh, to do in this session as well. Okay. So, what is IP address subnetting? This process involves determining the number of usable IP addresses within a given range, considering factors such as network address, broadcast address, and reserved addresses. Okay, here I'm telling you, okay, what is actually IP subnetting? So, briefly, once we define our network IP address, broadcast IP address, and whatever IP address in between them, that's done. Okay, so let's do some subnetting. First, we need to understand the concept of permutation. We can easily have 0 or 1 in each box. For instance, if we have two boxes, the number of possible combinations with 0 and 1 is 4, as shown below. Number of positions is 2 multiple 2 equal 4, 2 to the power of n. N here is the number of boxes. So that number of boxes very important. So uh, here we mentioned that, okay, respectively, we have a total of 32, which is 4 multiple 8 boxes. It's available for each IPv4 addresses, so the number of position is calculated as follows: 2 multiple 2, 2, 2, 2, 32 times, which is coming to this 4 billion 294,906 294,967,296 available IP addresses, which is actually the total IP addresses that we can have, but we have to actually subtract these IP addresses from some reserved IP addresses, which is roughly 588,514,204 IP addresses, which came to this number, which is 3 billion. And here I've been written some of the reserved IP addresses, which totally, if you sum up them, it will comes to this number. So here I mentioned all these, reserved IP addresses. I haven't seen them honestly, except those IPv4 private IP addresses. I haven't seen them, and the reason is definitely clear because uh, I haven't used them during my, networking engineering uh, uh, job. Uh, as I told you, if we add up all these reserved IP addresses and subtract them from the total IP addresses, we will get to that. Okay. Uh, just want to tell you about that permutation concept, which I'm pretty sure I talked about it previously, but just in order to have a recap. What is that permutation? Easy. Permutation is saying this. You got, for example, two boxes here. In in computer engineering, these two boxes can be called bits. Bit or plural actually pronunciation is bits. Okay, I'll tell you bit. One bit here, one bit here. How many possible possible condition you can have in each boxes. Two. Why two? Because you can have zero here or you can have one here. Am I right? Same for this one. Zero or one. Not both together. Zero or one. So let's write down the possible conditions. Possible conditions should be something like this for these two boxes. Zero, zero, or one, zero, or zero, one. All right? Or one, one. So one condition here. This is your first condition. This is second, third, and fourth. So totally, how many conditions we have here? One, two, three, four. Four condition, which is two multiple two. So we just need to understand this concept in order to get to the number of, available IP addresses and bits and stuff like that, or even the numbers, the decimal numbers. So I have actually talked about uh, this part, I think. Yeah, the concept of permutation. So number of positions comes to 2 multiple 2, which is 4, and n is the number of boxes. Respectively, we have a total of 32 boxes or bits. So that's why we got to this number. We could reach to this number. Okay. Now, okay, we can say approximately, although, we will getting to this number. Okay, approximately 3.7 billion IPv4 addresses are available for internet use. Many of them are already reserved, you have seen, and uh, this 3.7 is not included the already bought internet IP addresses by, because these internet IP addresses, uh, already been sold, many of them, so it is included them as well. Usually you need to use CIDR for private IPv4 subnet addresses, although AI can easily do this for you. It's important to understand the procedure. Yes, you need to know the procedure, although AI is doing it for you. It's just like you definitely, if you're going to use calculator, that's fine, but you need to know the concept of summing up, subtract, multiply, power, and stuff like that. Am I right? So that's why I believe that you need to know subnetting. Definitely, you need to know subnetting. Okay. Uh, from now on, I'm going to talk about a trick which made uh, subnetting very easy for me. Honestly, this trick uh, uh, helped me to do subnetting uh, as easier as possible. I've seen many network engineers are dealing, even network engineers have problem about subnetting. But once you learn this trick, which I myself use that, and I don't know how I learned this trick, maybe myself or uh, from the books or from many, many courses I have done, but just trust me. It is very useful. Okay, let's start with a prefix uh, larger. Okay, here I mentioned prefixes between 16 to 24, but let's start with the prefixes larger than slash 24, which is much easier. Okay, so for instance, you got the subnet here 10.10.10.0/24. So it is a subnet you could see in your networking interface card, configuration or stuff like that. So for this one, network IP address is the first IP address, which is 10.0, 10.10.10.0, and the broadcast is 10.10.10.255. So usable IP address, whatever between these two IP addresses are usable IP addresses, and these usable IP addresses are assignable to other network interfaces. So, okay, now uh, let's get to the tricks. I will actually provide this PDF file and this text to you, which I explain this trick to bit, but uh, let me go with an example and then we will get back to that. Okay, now let's get back to a bit complicated prefix, which is, for example, anything between 16 to 24. Let's take an example. If we're going to calculate the number of usable IP addresses for subnet 10.10.0.0/17, the total number of IP addresses, regardless of whether they are usable or now, is calculated as follows. So I told you this n is the box, okay? So the formula is 2 to the power of n minus 2. How we can get to that box? Okay, you might say, okay, for 10.10.0.0/17, how many boxes we will have? Let's go for it. Let's open up a new. Hmm, new one. So what is my IP address? 10 dot 10 dot 0 dot 0/17. If anyone give you this address, uh, just keep it in your mind. I will talk about that one later. But anyone give you a prefix like this, the first thing you have to do is think in between which uh, prefixes it is. And /8, /16, and /24 are very important prefixes. So this one is coming underneath this category. Okay, just keep it in your mind. So do you think this 17 is the number of boxes? No. Actually, the number of boxes will be 32 minus 17, which comes to 15. Why? Because this 17 is actually representing to you the network number. It's about the fixed boxes, not about the boxes which you can actually change. So once you got something like this, you will have three, okay, 8 boxes here, then again blah, 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 8 boxes here. Okay, these ones comes to prefix 16, and one box here, which is again fix, which makes it to 17, the prefix, but the rest 7 boxes in that octet will be free. One, two, three, 4, 5, 6, 7, plus, let's go till 8 here. So you will have 8 boxes here at the fourth octet, please 7 boxes here. So 7 plus 8 is 15. What is this 15? As per the permutation principle, which I told you before, you have 15 boxes in which you can put 0 or 1 or 0. 1 or 0. So you can put 1, 0. You can put both of them, 0 or 1. They all together comes to 2 multiple 2 multiple 2, blah, 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 till the end, which is 2 to the power of 15, which is a very large number. So, okay, let's get back to this one. For prefixes between 16 to 24, let's take an example. We are going to calculate the number of usable IP addresses for subnet 10.10. I done it. Okay. So that was the 2 to the power of 15 was IP addresses. You have to minus it from 2. That 2 is the broadcast and the network IP address. All right. Let me see it. What will be the number? I think the number would be 32,768 IP addresses, and if you minus it from 2, you will have 32,766 available IP addresses. So I've mentioned here as well. So the 15 is the formula represent the number of available position to be filled out by 0 or 1. The minus 2 is the network address 10.10, which is the first IP address in the range, and the broadcast address, which is 10.10.127, 127, 255, which are usable. You might ask, okay, why this one is or broadcast IP address? Why it is not? Okay, let's get back to picture. Let's open up a new one. Okay, you seen that? Okay, or last usable IP address, sorry, or last IP address, which is or broadcast IP address, is 10.10.127.255. So why it is not 255? Because of this slash 17. If you had slash 16, you were right. You could have broadcast IP addresses as 255. But since you have that slash 17, it means that you already got one box already reserved here. And since it is reserved, it actually give you that 127 number. So I myself calculate it like this: just 256. See how many bits are coming here? One bit, one box. One box is coming here to be reserved for the network. So what I do, I just divide it to two. If that one box was two box, for example, instead of 17, I had slash 18, I would have divided, that division would have been 256 minus 4. So it comes to 128, and this comes to 64. So this is the way I actually remember how to map these numbers. It is very important. This mapping is very important. Let me show you. So for 16, map to uh, 256. Even for slash 24, I map it to 256. It doesn't matter because I'm just going to uh, calculate this number which is inside one octet. Even for slash 8, I map it to 256. So once slash, okay, let's get back here. Okay, a slash 16 map to 256. Slash 17 map to 128. Slash 18 map to 64. Slash 19 map to 32. Slash 20, and so on you go, 16. And you will go to the end, okay? At the end, I believe slash 20, okay, since it is important, let me have it like this. 21 like this, 22 to 4, 23 to 2, and 24 to 0. Once I say 0, because I can say 0 because it is coming back to 256. So here I mention another example for you as well, which is, this is an example. For example, you could assign 10.10.32.0.20 to your large marketing department if you do CIDR. So here our network IP address is 10.10.32.0 and the broadcast is 10.10.47.255. All addresses between are available IP addresses. Okay, let's go to this number. So you know that it shouldn't, it's not mandatory for them to be for those octet numbers, for example, all of them, first, second, third, and fourth octet to be started from 0. So let's get back to this number 10.10.32.0 slash 20. Okay, let me open up a new paint. Okay, we have 10.10.32.0 slash 20. So a slash 20, I told you in previous mapping, is mapped to 16. This 16 has a lot of meaning. It is the number of all IP addresses in third octet. This is third octet. This is first octet. Yeah, you know that. So once you have 16 there, so that 16 will be multiplied to how many available IP addresses we can have in fourth octet? 256. It is another way. Okay, now let's CIDR and split this IP address. I want to have four equal IP addresses from that. What I have to do, I have to actually divide 256 to this magical number 4. Anyway, you need 4 of them. So you will get to number 64. All right. So this 64, just keep it in your mind, this 64. Let me open up new page here. Okay, I had 192.168.0.0 slash 16 available. So for example, if I'm gonna divide it to 4 network, my third octet will be start, my second octet will be start from 64. This is the second. My third octet will start from 128 and just add up 64 to 128. I think we'll get to 192. Okay, this is fourth octet. So everything are relevant to this 64. So this 64, if you just put it inside instead of 0, it will give you another IP address. But in terms of the prefixes, we had that mapping. Don't actually make mistake with it. No, after splitting, forget that 64. Now let's get back to the mapping concept, which I talked about like previously. This is uh, relevant to 128. So this 128 is divided to 2. 18 is 64, which is divided to 4. Okay, so okay, this 64 and 4 and divide to 4. Okay, so our magic number. No, again, get back to 64. I just wanted to show you this splitting, but still this 64 is our magic number here. So what you have, if you're gonna divide it to 4 networks, you need to have this 18 as your prefixes. So this 18 here, let me show it with different color. This 18 will comes up and sit instead of this one. So via this procedure, you can understand, okay, what will be your prefixes in order to divide that network to 4. This is your third one. So if I get back to my text, uh, okay, I already assigned this IP address to my large marketing department. So in this case, uh, I will have, let's get back to, okay, open up. I said 10.10.32.0/20. Let's go to mapping. I told you 16 is mapped to 256, 17 to 120. Just do it in your mind. I believe that you can even pass, any networking questions in regarding subnetting with this trick for any of them. 18 it comes to 64. 19 is 32 and 20 is 16. You just mapped it to 16. So no, or magic number is 16. So what does this 16 mean? It means that you can just add 16 uh, more numbers to this number in order to get to your to the next, actually not the second CID or subnet of /20. So if you imagine it as a box, you will have you will have 16 multiple. So this is for third octet. How many for fourth octet? 256. So 16 multiple 256 will be your available IP addresses in this range. And okay, I told you if you add up this 16 to this 32, which will be 48, will be your next available subnet in this range. So what is the last IP address to reach to that 48? It is definitely 10.10.47 and 255. So this is your broadcast IP address. So don't forget this magic number. This magic number will do everything for you. I think 16 multiple 256. Just let me use my calculator. 16 multiple 256. Okay, it comes to 4096 IP addresses, which you can divide that network and this broadcast, and you can get to 4094 available IP addresses for that. All right. Okay, I told here as well the next available subnet could be 10.10.48.0.20. The third octet could be increased by 16 to 24. Just a trip Just a tip for you, the power of 4 comes from the difference between 20 and 16. I call /18, /16, and /24 the magic numbers. But anyway, I call this mapping also another magic number. So you got these 3 magic numbers, and you got these magic numbers. You can go for all of them. So it will go to till 23, which you can map it to 2, and /24 will get back to 256. So all you need to do is mapping these even a /8 to 256, 9 to 128. These mapping and plus /28, /8, /16, and /24 are your magic numbers. I think that's enough. So try to search on internet, try to ask ChatGPT. ChatGPT is doing subnetting very well these days because anyway, subnetting is very well formulated. So it can explain you, just give ChatGPT a number and it will actually provide you a solution how it got to this number. It got to this number, but don't forget the trick which I taught you and okay, that magic things. I know that it might be a bit, hard to understand it in first glance, but just try to practice it, and I'm pretty sure you will learn subnetting. If you couldn't learn subnetting, even if you couldn't, that's not important for your DevSecOps journey. Don't worry about that. But you at least need to know, the subnet mask, the prefixes, and the range of IP addresses. And I think that's enough for you. Thank you very much. Have a good one.